If you can, then I guess. So, all right, so here we go. So, sections, so transformation. Chris, what's a transformation?
It's a one-to-one change.
One-to-one change. John, give me one transformation and the word that defines it. Okay, reflex and flip. Okay, good. Ken, you give me a second one.
Rotation, turn.
Rotation, turn. Hope, give me a third.
Translation slide.
Translation slide.
Identity same.
Identity same. All right, so we're good so far, the four. Then we also did, so we had those. What did we translate? When you translate, what do you translate over? Dylan? When you translate it, when you translate something, what did you have to translate over? What kind of lines?
Parallel lines.
Good. And what kind of lines do you rotate around, Jenna? Which ones do you rotate around?
Oh, intersecting line?
Intersecting lines. Good. Or perpendicular. If you answer either one of those, I'll give it to you. Okay? What is the pre-image and what is the image? Sarah, what is the difference between the pre-image and the image?
The pre-image is the original thing, and the image is afterwards.
Okay, what you're being transformed to. Okay, good. Any questions up to this point? We're all good? All right. If you're looking for the magnitude of a rotation, how do you find the magnitude of the rotation? Yes and no. You can't necessarily do that. How would you do the rotation? Does everybody know? Off the top of their head? So if you have two lines, it's the angle times 2 for the whole magnitude. Does that make sense? And if you want what the angle is, you would divide the magnitude in half. Does that make sense to everybody? Do you ever remember that? We didn't lecture over it. You did it in the homework, and you had to do some of that in homework. So if I were to say to you the whole magnitude of the rotation is 90, then you can say, if you had to draw lines, then the lines have to be at what angle? 45. Does that make sense? Because you have two rotations, two flips. So you rotate 90 full. All right, and everybody got that? All right, then we did 6 characteristics. 6 characteristics of isometry. All right, yes, Chloe. Oh, yeah. All right. So what are the 6 characteristics of isometry? Give me one.
Angle measure.
Angle measure. Brandon, give me a second one.
Betweenness.
Betweenness. B. C.
Comeliness.
D. Tyler.
Distance.
P. T. All right. So now, listen carefully. What do all those do? What does isometry do? It maintains what 2 things? What does it mean? The distance or the size and the
Congruent.
shape. Okay, so listen, here's how you remember isometry. Listen, it preserves 2 major things. Size, shape. Size, shape. Remember that because today's lesson, you're going to realize that this next transformation does not preserve size and shape. The 4 that we've talked about up to this point preserve size and shape. Preserve size and shape because they are isometry. And they have those 6 characteristics. Does everybody understand? Are we good? So then yesterday we talked about symmetry. What was symmetry? Cut in. Okay, we have exactly in half. I had given you there were 3 types of symmetry. The first was line symmetry, which we covered and you guys understand. The second one was point symmetry, and the third was rotational symmetry. Rotational symmetry was what? Anybody remember what I gave you yesterday, Natalie? Do you remember? What was rotational symmetry?
How many times you can rotate?
Yeah, how many times? So if I have this marker and I rotate this marker, can I rotate it at all without having back to the original? And it'd be exactly the same. No, because there's no cap. Does that make sense? All right, and even if the letters aren't right, does that make sense? So at the end of the day, you can't rotate this and do that. If it goes full circle, what is that really? It's an identity, right? So it's not really a new thing. It's the same exact thing. So rotation is based on, you can rotate it based on what you can do. So like if I have this, the problem is these don't really work because of these buttons here, but if these buttons were filled in and this all was exactly identical, there's one rotation. Does that make sense? It's exactly the same if those buttons are filled in. Does that make sense? Okay, but because those buttons are different, it actually doesn't ever rotate. You can't rotate this to make it symmetrical. Does that make sense to everybody? All right. So if I had taken this and put it here, then I could rotate the back and it would have exactly the same on both of them. Does that make sense? Is everybody following this? So it has to be the exact rotation to look exactly the same.
Actually, the camera.
Huh? I'm covering the camera, you can't tell. All right, so any questions on the rotational symmetry? Now, how do you find that? It's based on the number of times you can rotate it. And then that's when you would divide 360 by that number. So that's why when we had a star, right? When you had a star, I forgot what I was drawing there for a second. Dylan, why are you laughing at me? Yeah, don't laugh.
It's really good. Why
All right, so it's the best star ever. Chris, I'm putting this in for Max, and I'm going to get first place in monochromatic drawing.
For abstract.
Is that a word?
Yes, and
Okay.
just
So
I'm not doing that.
I'm not doing, but it's blue. Oh,
Yeah.
so it has to be polychromatic.
Oh no, it's able to be blue. It just can't be any other color.
Oh, then I got it.
Yeah.
Yeah, see, I owned it.
Will you put it in for abstract art?
Abstract art. This is never mind. All right, absentee talent art. All right, so that's fine. All right, so how many times would we rotate this? So each little thing, right? So each little point, right?
Do you have a
I didn't talk
problem with
about your art, absentee art, okay? I was talking about mine, all right? Don't get upset. She's crying now.
Some of the arts and maths are.
So, any questions? Now, here's the difference between point symmetry and rotational symmetry. Okay, so here's the difference. This is all you have to make sure to know for this lesson. Rotational, it's every time it rotates, so it can be 72. So if I have this is 5. So each rotation is 72. The next one is going to be 144. The next one's going to be 216. The next one's going to be 360. Does that make sense? Does that make sense? You have those rotations. You would just divide it by 5, and each rotation is 72, and it added up. Does that make sense to everybody? Now, when you do point symmetry, and this is the difference. We didn't cover this yesterday, and so when we'll go back and do 1 to 12 real quick with point symmetry and rotational symmetry. Point symmetry is a full 180 rotation. So if it has 180 rotation, then it works. So would this be point symmetry? The answer is no. Why not? It doesn't stop at 180. Does that make sense? Okay, is everybody following me on this? So this one here, let's say we have a square. Let's do a square. I'll do my perfect drawing here. Perfect square here. All right, can I rotate a square?
Yes.
I can. How many times can I rotate a square?
4.
So 1, 2, 3, 4, right? Does that make sense? Now watch carefully. Think about it. Which would it have point symmetry now?
Yeah.
Yes. Because why? Can I rotate it 180 degrees?
Yeah.
Yes. Because this would be 90, 180, 270, 360, right? So if it has the 180, then it is point symmetry. That's the difference between point and rotational. Does everybody understand the difference?
Yes.
Yes.
How do you said it can go 180. How do you determine if it can go?
Just do.
You just divide it like you do rotational. 90. So you solve rotational first, and if one of the answers is 90, 180, 270, then if 180 is one of the answers, then it's also point. Okay? So it's like that's just a more direct answer. Okay? Yes.
So if a shape does not have rotational symmetry, it automatically can't have
Yeah.
point symmetry.
Right. Okay, so go back to your homework assignment 1 to 12. Now let's do that together very quickly. We'll knock this out in like 5 minutes this way. All right, so everybody go back to your number 1. Everybody there? The airplane. We already did the line symmetries. Everybody good with that?
Yes.
Everybody was fine with line symmetry. Didn't need to review that anymore. And by the way, we just reviewed the entire chapter. Okay, so now if you review this weekend and then you review Monday, you probably won't even need to study for this on Wednesday. Okay. All right. Number one. Is there a rotational or point? Well, first off, just answer, is there rotational?
No.
No, so if there's no rotational, then there's no point.
Yep.
Okay?
Yay.
There's no point to it if there is no rotational. If you can't rotate it, there's no point. All right, number two, sorry. Dry humor. I love it. All right, number 2. It's early, so. Number 2.
I'm cracking up.
Danielle. Is it rotational? Can you rotate it?
Yes.
How many times?
360.
How many times can you rotate it? Answer that question. How many times can you rotate it? 1, 2, 3, 4, 5, 6, 7, 8. What?
8 times.
You sure?
8.
You gotta remember the inside has to look exactly the same too.
4.
4, good. You can rotate it 4 times. So what's the degree of rotation? 90. So 90, 180, 270, 360 comes back to normal. So is it point symmetry?
Yes.
Good. Number 3.
No.
No and no. Good. 4. Tally. Okay, everybody listen. Shh. Don't talk, please. Number 4. She says it's rotational. What would the rotation be? How many times can you rotate it? 2. Good. So therefore, your rotation is how much degree?
180.
Good. And 180. So therefore, is it point symmetry as well? Perfect. Number 5. Sarah?
No.
No and so therefore, no and
No.
good. Double no. Double negative. This is the only time you're allowed to do double negatives.
Why couldn't I?
Because the bottom's not.
Because you can't rotate that and be exactly the same.
Okay.
Okay? Number 6. Number 6. Jenna. It's on the board. The same shape. Mine's better though.
Are you kidding? No. No.
You mean?
No?
Well, I told you this can do how many times?
Oh,
Good. So 360 divided by 5? 72. Good. 72. 72, 144. So is there a 180 in there?
No.
No. So is it point symmetry? No. Good. Number 7. Now here's the tricky. Can I rotate this one? Look. Can I rotate this? I can.
Yes.
180, yes?
Yes.
So is it, if it's rotational and it's 180 rotational, then what is it?
Point.
Good. Number 8. Number 8, John? No and no. Number 9. Yeah. How many degrees?
36.
45. Good.
Wait, what?
45.
Why would you have
See the little holes? Count the number of holes.
8?
How many? 1, 2, 3, 4, 5, 6, 7, 8. So look, you can rotate. So divide it by 8. What does that give you? Hey, so how many times? 45, 90, 135, 180, 225, 260, or 270, 315, it's 360.
Are you doing this from your head?
No,
He's
he's
writing it on
writing
paper.
See your calculator.
No.
I'm cheating. I've got it right here.
Yeah, you
Let
gotta
me answer them. I'm that fast.
contact lens.
No.
Too much
This is-
attitude in this.
All right, listen. So, is it point? Is it point?
Yeah.
Yes. Good. All right. Number 9.
4.
Yes. Or 10. Sorry, 10.
90 degrees.
90.
Good going.
And yes. 11.
90 degrees.
90 degrees and yes. Good. Any questions on rotation and point? All right, good. Starting 10.6. Here's your notes. Get your notes out. 10.6. I want to give you this and then give you a few minutes to work on the homework. And remember, guys, Pi Day is Thursday. Wednesday is the test. And Monday, Tuesday, we'll review. Typically, I'll get probably what we'll do Monday, because I don't want to give you a ton of homework over the weekend. You can do it. I'll give you the first 15 minutes of class on Monday to work on the homework I'm going to assign. Okay? So do a little bit in study hall today. Do a little bit for homework. But I'll give you 15 minutes to do the homework in class. Okay? Is that fair? Try to be as fair as possible. Yes?
Did you say this was the last chapter we're doing?
No.
So
We'll do chapter 11, chapter 12, and chapter 9. We'll come back to chapter 9, and if I have to, I'll get another book so we can get started.
No,
on that, 'cause
please
we are just on top of our game. Yeah.
Dude.
All right.
We're all
We can't
wrong.
go
We gotta
through pre-algebra.
So
We do 2 geometry.
we can probably do 2. Well, we did this session. Yeah. All right. So here we go. So we just did it. There are 4 transformations we've covered so far. We covered reflection, translation, rotation, identity transformation. Today I'm going to give you the 5th one. The 5th one is called a dilation. A dilation.
Like my eyes
Wasn't
when I get
symmetry the
excited.
fifth one?
No, symmetry was a definition to help you understand those four. Number 5 is a dilation. Dilation. What is a dilation? It's like, for instance, in your eye when your pupil, when we turn the lights off and turn them back on. I was going to do it to you. I was going to go in the church chapel and use the pad and turn them up and down. And if you could see your eye as I turn the lights up and down. All right, guys. If I did that, what you would notice is your eye would actually get bigger. The pupil in the middle of your eye would get bigger and smaller.
Wait,
Okay?
did you go
They would
do it?
dilate. No, you won't be able to see it. Especially in your eyes, you would not be able to see it because they're so
Yeah, your
dark.
eyes are really
Now, so here's the point. The point is this. That pupil is dilating. Is it changing the shape? No. Is it changing the size?
Yeah.
Yes. So notice, listen carefully. The first 4, rotation, translation, reflection, identity, they preserved shape and size. A dilation only preserves the shape. Now listen, everybody listen. A dilation only preserves the shape. You may want to write that down somewhere. Only preserves the shape. P-R-E.
Wait a minute. I know how to spell something.
Now,
You didn't?
the word is actually 2 words because it can be either way. Guys, enlarge and shrink. So like all the other ones have a 1-word definition, dilation has a 2-word definition because it's actually enlarge or shrink. Okay? It's changing the size. Now, everybody's still with me?
Yeah.
So, let's review again. Watch. A, B, C, D, P, T. A, angle. Betweenus. Collinear. Distance. Parallel. And triangle. Now,
You sound like zombies.
yes, you do. But, all right, watch carefully. Now, listen, look with me at the board. There are 6 of those. Those are the characteristics of symmetry. Those 6 characteristics apply to the first 4. Which of these 6 characteristics are going to apply to dilations? Because remember, what's the difference? The difference is a dilation preserves what?
Just the shape.
And these other 4 preserve shape and size. So of these 6 characteristics, which ones preserve shape and which ones preserve size? Brandon, give me 2. Which ones preserve shape? What deal with shape and which deals with size?
Distance.
Distance deals with size. Give me another one that deals with size. Somebody else.
Parallel?
Nope. Tally?
Angle.
Nope. Say what you said before.
Triangle.
Triangle congruence. These 2 deal with size. Parallel doesn't because all that deals with is where it's located, right? And the shape of it. You're just moving it from one place to the other. It doesn't do anything with the shape. Collinear, making sure the shape stays the same. Betweenus, shape stays the same. Angle measure, shape stays the same. These 2 characteristics are the ones that don't apply to a dilation. So when you have to, if I on the test ask you what are the 4 characteristics of a dilation, you would say A, B, C, P. Does that make sense? So so on the test, I can promise you there's a question on the test. Name the 6 characteristics and mark the 4 characteristics that are dilations. So what are the 4 characteristics that are dilations? A, B, C, P. Does that make sense to everybody? Is everybody following me? This is not over the top yet, right?
No.
Okay, good. Now, how do we get a dilation? What is a dilation? So, the dilation has what we would call a scale factor. A scale factor. This is the key to dilation, so make sure you get this. Okay? Scale factor. What's a scale factor?
Proportion.
It's not when I step on the scale in the morning and go, whoo, that's a factor. You know, scales, that's not a fear factor kind of thing. It's a scale factor. What is a scale factor? Somebody tell me what that is. What do you? Proportion. What is a proportion? When we're talking about a shape,
Fraction.
when we talk about a fraction, what do we think of?
Percentage.
We're thinking of bigger or smaller. If it's a fraction, are we thinking of bigger or smaller?
Smaller.
Smaller, good. So, everybody listen. If it's a fractional scale factor, it's getting smaller. Okay? So watch carefully. I'm going to write this down. Write it down this way so you can understand it. They use the letter K to represent scale factor. So, when the scale factor is less than 1, but greater than 0, and I'll explain this, then it would be getting smaller. In other words, fraction, and I'll explain. Okay? Smaller, or a fraction. Okay, so listen. Why did I have to say greater than 0? What happens when something gets to 0?
Becomes negative.
It becomes nothing. Because 0 times something is what?
0.
So it has to be bigger than 0. It has to be less than 1. So by the way, what is that? That's any fraction known to man. 1/12, 1/13, 1/5, 1/7, right? All those fractions are going to make that shape that much smaller. Is that fair to everybody? Everybody got me on this? You're changing that shape in the fractional standpoint. Now, if k is greater than 1, what do you think is going to happen? Bigger, larger. Okay, this is a whole number, by the way. Whole number. Whole number. And what happens if k is equal to 1?
Then the shape hasn't changed.
Think about it. If I'm, like you remember, I want an actual size, what's the scale factor? Same, right? It's 1. Like, does that make sense to everybody? It's not getting bigger. Bigger would be timesing it. Smaller takes a fraction of it. If I want the exact shape, then it's 1. So k equals 1 is same. All right, does everybody understand scale factor? So let's do an illustration. And you still have 10 minutes to work on your homework when we finish this. Isn't this awesome? So if I have a shape, all right, and this is going to be, and how do we remember? How do we know if it's a which one's the old, new shape and which one's the old shape? What? So which one's the pre-image and which one's the image? Pre-image, image, right? Okay, so if it has tick marks, it's the new image, right? So here's the other thing I forgot to give you. Scale factor is what? What do you think it is? It's going to be image over pre-image. Image over pre-image. So you always set that up. So look over here at this drawing. Which one's the image, class? Which one's the image? 30. What's the pre-image?
15.
30 over 15 equals?
2.
My scale factor is what?
2.
So,
Greater than 1.
does that make sense? It's greater than 1. So therefore my shape is getting what?
Bigger.
Is everybody following me?
Oh, this is
Is everybody following me?
Yeah.
So you would say enlarging, because the scale factor is 2. So let's just, for kicks and giggles, if I change this right here. Now, which one's the image, which one's the pre-image?
15.
Okay, so it's going to be 15 over,
30.
which is
1/2.
fraction. Woo, getting smaller. Now, remember, these are the same shape. So the shapes are always going to be the same. The sizes are going to change, yes? So if this one changes in 2, what do you think this one would be? What happens if I had 40 here, and what's this? What do you think that's going to be?
20.
Why? Because it's going to be half of it. Is everybody following this? So you're changing the whole shape, but you're changing the whole size of that thing, but you're not changing the shape. Is everybody following me on dilations? Okay? All right, any questions on dilations? So what they're going to do is they're going to have you, so let's say I have a shape like this. and they give you a point C. And they say to you, here's your shape, make this shape, oversized C, 2 times bigger. Well, how would I make this 2 times bigger? Let me show you how you would draw this. This is the other section. What you'll do is you'll draw a line like this. You'll draw a line like this, coming through the shape. Okay, so I need this to be 2 times bigger. So if this is the shape, this is a size, I want that 2 times bigger. Okay, so that's about where you would put it. Oops, I went the wrong way, sorry. My fault. So it goes this way. Okay? That shape, if I were to measure that, it would be about 2 times bigger. It wouldn't be perfect. But that's all they're doing is they're trying to say, okay, make it 2 times bigger, make it 5 times bigger. So if I wanted this shape to be half the size, where would I draw it on my drawing? Down here. So probably about here. Okay? And there we go. Does that make sense? So that one's half, that one's the original, and that one's bigger. Does everybody understand how we're drawing these? Any questions on dilations? All right, so for homework, 1 to page 502, 1 to 15 odd. Number 17, and then 22 to 27, or 22 to 31. So 1 to 15 odd. 17, 22 to 31 odd. So 23, sorry. Okay? Page 502. You guys are, hey, are any other classes in page 500 in your books?
No.
Man, that's awesome.
Well, actually, we learned, yeah.
Sweet. Finishing books, taking names. All right, any questions? All right, so start working. You got about not too much time, but about 5 minutes.